Okay, so we have to start non-uniform circular motion. उससे पहले आपका सेंट्रीपिटल एक्सेलरेशन कल रह गया था ना. सेंट्रीपिटल एक्सेलरेशन मैंने बोला था कल टेकअप करेंगे, या सेंट्रीपिटल एक्सेलरेशन भी आपका रह गया. इसके नोट्स आपको साथ साथ बनाने पड़ेंगे, ठीक है. कोशिश करना सारे नोट्स आज आप साथ साथ बनाओ. जस्ट वेट. अच्छा, सेंट्रीपिटल एक्सेलरेशन नाम से क्या समझ में आ रहा है आप लोगों को? सेंट्रीपिटल एक्सेलरेशन के कुछ तो ऐसा लग रहा होगा कि सेंटर के टुवर्ड्स लग रहा है. बाकी साइड में डायग्राम देखो, लेफ्ट हैंड साइड पर डायग्राम देखो. एसी 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 करके एक मार्किंग बनी हुई है. कैन यू सी द डायग्राम एंड कैन यू सी द positioning of the arrow head AC? Is the arrow pointing towards the center of the circle? The arrowhead, which is represented by the alphabet AC, it is pointing towards the center of the circle. ध्यान से देखो, हर एक केस में आप देखो सेंटर ऑफ द सर्कल के तरफ वो पॉइंट कर रहा है, एकदम सेंटर सर्कल के. It is pointing exactly at the center of the circle. So you can understand this by the word centripetal. That's something, this acceleration, centripetal acceleration, has something to do with the center of the circle. It has something to do with the center of the circle. Now, what is the exact meaning and definition also I'll write for you. Don't worry. Okay, first I'll do one thing. I'll write the definition. क्योंकि इसमें definition मैंने नहीं लिखी हुई है, सिर्फ formula लिखा हुआ है. First I will write the definition, then I will explain you. Just a minute. क्या वो ऑन क्यों नहीं हुआ? आज मेरा टैब ऑन नहीं हुआ. यप, हो गया. अच्छा, कल कोई लास्ट क्वेश्चन में डाउट तो नहीं था जो लास्ट क्वेश्चन सॉल्व किया था? मुझे एक आध बच्चे का मैसेज आया बाद में कि सर लास्ट क्वेश्चन रिपीट कराना है, तो मैंने वैसे तो इन चैट ही बता दिया टेलीग्राम पर उनको. बट अगर आप लोगों को लगता है तो आप मुझे क्लास में ही बता दिया करो कि सर सॉल्यूशन रिपीट होता है. वैसे लास्ट क्लास में कौन सा क्वेश्चन, लास्ट क्वेश्चन क्या किया था हमने? किसी ने बोला नहीं तो मैंने रिपीट कराया भी नहीं इसको. किया था हमने कोई क्वेश्चन इसके बाद? ये वाला ना, ये समझ में नहीं आया था आप लोगों को? द लास्ट क्वेश्चन ऑफ द लास्ट क्लास, यस्टरडेज क्लास, a rotating wheel, because one student messaged me after the class, so I thought of asking all of you. आप लोगों को अगर नहीं समझ में आया तो आप बता दो, हम अभी भी इसको सॉल्व कर सकते हैं. बट यहाँ से आगे बढ़ जाऊंगा फिर नहीं करेंगे. और अगर क्लियर हो तो बता दो सर क्लियर है, फिर हम आगे का टॉपिक सेंट्रिपिटल एक्सेलरेशन स्टार्ट कर देंगे. और वो आप कौन सा था जो मैं, एक सेकंड रुको, उस आपका नाम ही भूल गया मैं, नोट वाले आपका. लेट मी सी माय विंडोज. निकोड़ो. ओके, इस आज हम इनकोड यूज करेंगे, इसलिए मैं आपको कह रहा था कि अपने नोट्स आज के आपको जो जो इंपॉर्टेंट लगे अब साथ में लिखते हुए चलना. सो राइट टुडेज नोट्स साइड बाय साइड. कोई नया बच्चा ज्वाइन तो नहीं हुआ? Prasanna, once explain sir, clear to me, clear to me, clear to me. Once explain sir. Okay Prasanna, I'll explain it once again. Wait. Okay, I'll explain it here only in Encodo. क्या क्वेश्चन था लास्ट क्लास का? Let me just check. This question was a rotating wheel changes angular speed from 1800 to 3000. 800 RPM to 3000 RPM. ये RPM में था. Just a minute. A rotating wheel is changing its angular speed from 1800 RPM to 3000 RPM. Now, what is RPM? RPM is rotation per minute. RPM is rotation per minute. And this is the only checkpoint in this question. Okay. Why do I say this is checkpoint? Prasanna, because do you remember what is the SI unit of frequency that I told you? What is the SI unit of frequency? I told you SI unit of frequency is revolution per second. I hope you remember that. SI unit of frequency is revolution per second, and sorry, RPM is revolution per minute. Now, what's the difference here? The difference is the question is saying that a change in angular speed is given, but instead the change in the frequency is given. This is frequency. 1800 RPM is your frequency and not your angular speed. And the time for this change is 20 seconds. And they asked you to calculate what? Angular acceleration. They asked you to calculate angular acceleration based on this data. So the simple formula for calculating angular acceleration. Okay, since the time is 20 seconds, which is a greater time, so you will calculate alpha average. What is alpha average? Average angular acceleration. What was the formula? Omega 2 minus omega 1 upon total time, which was t2 minus t1. So now you have to write omega, which is your angular velocity. This is your angular velocity in the terms of frequency. Okay. Why in the terms of frequency you need to write? Because the change in frequency is given to you and they are saying angular speed. So this is a contrast in the question. The question is claiming that they are giving you change in angular speed, but instead they are giving you change in frequency. So you need to convert this frequency into angular velocity. And how do you calculate angular velocity? By using frequency. The formula was omega is equals to 2 pi f, where f was the frequency and 2 pi is a constant. Okay, so this is the formula for converting or for calculating angular velocity or angular speed from the frequency of the particle. So we'll apply this formula here. 2 pi, we will take common. We'll simply write f2 minus f1, f2 minus f1 upon t2 minus t1 is nothing but 20 minus 0. So this will be 2 pi. F2 is your 3000 minus 1800 upon 20. So if you solve this further, one more catch is there, that this is revolution per minute. This is revolution per minute. RPM is revolution. PM stands for per minute. But the SI unit of frequency is revolution per second. So you need to convert this frequency of 1800 RPM to 1800 to RPS, revolution per second. You have to convert RPM into RPS. From revolution per minute, you have to convert into revolution per second. So how will you do it? You will simply write 1800 divided by 60, okay, which will give you 30. So your F1 is 30. I'll accordingly change it. This is 30. And this F2 on the similar basis will be 50. This will be 50. Why 50? 3000 upon 60, you will get 50. I hope you understand why we did the conversion. We did the conversion because the frequency was in revolution per minute. Frequency was in revolution per minute. RPM, and we converted it to revolution per second because this is the acceptable SI unit. This is what is used for solving questions. So I hope you can solve this further now, Prasanna, and just you have to calculate the answer by solving this. The answer will be 2 pi radian per second square because acceleration is always in radian per second square. Okay, because 50 minus 30 will be 20 and 20 and 20 will get cancelled. So the final answer will be 2 pi, which you can already see here. Now let me start with what? Okay, मैंने आपको एनालॉजी कराई थी क्या कांस्टेंट एंगुलर एक्सेलरेशन के केस में? ओके, एक बार क्विकली अगर नहीं कराई तो जस्ट यहाँ पर देख लो. फॉर कांस्टेंट एंगुलर एक्सेलरेशन वी कैन replace all the equations of motion in all the equations of motions. We can replace all those equation by angular variables. ठीक है, जो linear motions में हम equation लगाते थे v is equals to u plus at वगैरह वाली, उन सबको आप रिप्लेस कर सकते हो एंगुलर वेरिएबल्स के साथ. सो और वहां पर क्या कंडीशन थी कि वहां पर कांस्टेंट एक्सेलरेशन था और यहाँ पर कांस्टेंट एंगुलर एक्सेलरेशन होना चाहिए उनको अप्लाई करने के लिए. दिस वाज द कंडीशन इन द केस ऑफ linear motion, that the equations of motion were applicable or acceptable only when the motion is under a constant acceleration. In this case, if the motion is under constant angular acceleration, then all the equations of motion which were applicable for linear motion will also be applicable for angular motion. But the way of writing is different because v is equals to u plus at has been replaced by omega is equals to omega naught plus alpha t. Hope this is clear. Again, then s is equals to ut plus half at square is replaced by theta is equals to omega naught t plus half alpha t square. ये replacement equations हैं. The third one, v square minus u square is equals to 2as. V square minus u square is equals to 2as. In angular motion, will be replaced by the angular variables, and it will be omega square minus omega naught square is equals to 2 alpha theta. Okay. Similarly, the average angular velocity will be initial velocity plus final velocity upon 2. Okay, this is the replaced form of what? V average, which was used to be u plus v by 2. Okay, similarly, theta is equals to, this is what? Distance covered will be average displacement, will be average velocity multiplied by time taken. And there was another equation s nth, distance covered in nth second, which was used to be u plus a by 2 into 2t minus 1. This will also be replaced by same variables. Theta is equals to omega naught plus alpha by 2 into 2t minus 1. Okay, so these are the analogy between the linear equations and the angular equations. And remember the condition, ये कब लगती है? जब angular acceleration आपको दिया हुआ हो, ठीक है. बाकी आप समझ गए होंगे, s को थीटा से रिप्लेस करते हैं, v को ओमेगा से, e को अल्फा से, ठीक है. बाकी सारी चीजें सेम है, बट आपको बस एक एनालॉजी समझानी थी. ओके, so let us start with what? Centripetal या radial acceleration. What is centripetal or radial acceleration? First, okay, first I will write the definition and then I will explain, ठीक है. When a particle is moving in uniform circular motion, definition को साथ साथ समझते चलना, ठीक है. Try to understand what I am writing with me only. When a particle is moving in uniform circular motion, its speed remains constant. Okay, its speed remains constant. Why speed remains constant? Because it is uniform circular motion. Okay, you all know what is the meaning of uniform. What is the meaning of uniform circular motion? A motion in which the speed remains constant. Okay, so I ate the word remain and I just wrote constant. Speed remains constant. Now, the velocity of particle will change now due to change in direction of velocity. Okay, this was the first para. The second para is the acceleration oh, बहुत ध्यान से समझना, मैं बार बार इसलिए आराम से पढ़ा रहा हूं क्योंकि काफी इंपॉर्टेंट कॉन्सेप्ट है, वेरी इंपॉर्टेंट कॉन्सेप्ट. So the acceleration due to change in direction of velocity is called centripetal acceleration. समझ में आया कुछ? नहीं सर. देखो, the definition says when a particle is moving in uniform circular motion, its speed remains constant. ये बात तो समझ में आ गई होगी that when a particle is moving in uniform circular motion, its speed will remain constant because that is the meaning of uniform circular motion. ठीक है, यूनिफॉर्म का मतलब ही होता है कि स्पीड कांस्टेंट है. ठीक है, अब एक बात आप सोचो कि स्पीड अगर कांस्टेंट है तो क्या ये जरूरी है कि वेलोसिटी भी कांस्टेंट होगी? इफ आई आस्क यू दिस, if the speed of the particle is constant, is it necessary that the velocity of the particle will also be constant? All the students who have not revised the fourth chapter vector will say yes. ठीक है ना? But the answer is not yes. If the speed of the particle is constant, it does not necessarily mean that the velocity of the particle will be constant, because velocity is a vector quantity and vector quantity depends upon magnitude of as well as the direction. And in circular motion, the direction of velocity is continuously changing. Okay, can you imagine this point? Let me draw. Let me draw. क्या हो रहा है ये? Can you now see if a particle is moving in circular motion, then the direction of velocity is changing always and every time. देखो सर्कुलर मोशन में अगर आप यहाँ पे हो तो आपकी वेलोसिटी इस डायरेक्शन में है, अगर आप यहाँ पे हो तो आपकी वेलोसिटी इस डायरेक्शन में है, अगर आप यहाँ पे हो तो आपकी वेलोसिटी इस डायरेक्शन में है, अगर आप यहाँ पे हो तो आपकी वेलोसिटी इस डायरेक्शन में है, अगर आप यहाँ पे हो अगेन तो आपकी वेलोसिटी इस डायरेक्शन में है, फिर जब यहाँ पे हो तो इस डायरेक्शन में है, जब यहाँ पे हो तो इस डायरेक्शन में है. इफ यू आर मूविंग क्लॉकवाइज, if you are moving clockwise, so the direction in circular motion is always changing. Direction of velocity is always changing, and since velocity is a vector quantity, and if the direction of the velocity is changing, then we can say that the velocity is not constant. Velocity is not constant in circular motion. क्यों नहीं होती velocity constant circular motion में? क्योंकि velocity का जो direction है वो लगातार change हो रहा है, and change in direction की वजह से velocity constant नहीं होती. ठीक है, वेलोसिटी को कांस्टेंट करना है तो आपको स्पीड को भी और डायरेक्शन को भी कांस्टेंट करना पड़ेगा, पर क्योंकि सर्कुलर मोशन है डायरेक्शन तो कांस्टेंट हो नहीं सकती, इसलिए velocity will not be constant, and due to the change in the direction of velocity a certain acceleration is produced. Okay, the acceleration is produced due to change in the velocity of the particle which is undergoing circular motion, and this acceleration is called as centripetal acceleration. इसी को हम centripetal acceleration बोलते हैं. ठीक है, now what you should always keep in mind is that first of all, wherever you see circular motion, their centripetal acceleration is bound to be present. Okay, जहां पे सर्कुलर मोशन की बात होगी वहां पे सेंट्रीपिटल मोशन होगा, सेंट्रीपिटल एक्सेलरेशन होगा ही होगा. Why centripetal acceleration is always there in all type of circular motion? Because centripetal acceleration is due to change in the direction uh, of the velocity of the particle. ठीक है, change in direction of the velocity of the particle is producing centripetal acceleration, और this change in direction of the particle while undergoing circular motion is inevitable. ठीक है, इसको आप चेंज ही नहीं कर सकते. जब तक सर्कुलर मोशन में हो आपकी वेलोसिटी हर पॉइंट पे चेंज हो रही है, हर बदलते पॉइंट के साथ आपकी वेलोसिटी चेंज हो रही है. तो ये मतलब क्यों चेंज हो रही है, और डायरेक्शन में चेंज होने की वजह से, तो आप इसको रोक नहीं सकते हैं, और इसी वजह से सेंट्रीपिटल एक्सेलरेशन यहाँ पर प्रेजेंट होता है. नाउ सेंट्रीपिटल एक्सेलरेशन is present only because of the change in direction of a particle's velocity under circular motion. What you should again also keep in mind is that the centripetal acceleration is always directed towards the center. Okay, centripetal acceleration, centripetal acceleration, मार्कर लेट चल रहा है, is directed towards center of circle. So this is what you should always remember, that the centripetal acceleration is always directed towards the center of circle. That is why I showed you that diagram. I showed you one diagram now in the open board. Just wait a minute. This diagram I'm talking about. हाँ एक सेकंड रुकना, अभी करता हूँ, एक सेकंड. Yes, yes. वैसे I hope you guys are clear about the centripetal acceleration. So you see, यहाँ पे देखो, this centripetal acceleration is always directed toward the center of the circle. This is the center of the circle C. Okay, at this point also the velocity is in this direction. The centripetal acceleration is directed towards the center. When you're at this point, the velocity is downwards. The centripetal acceleration is towards the center. Okay, same in every case. So this is centripetal acceleration perpendicular to the velocity at all times. Perpendicular to velocity at all times and radially inwards. Now that is why we also call it radial acceleration, because आप देखो, why we call it radial acceleration, because if I join this line, if I extend this line towards the till the center of the circle, this will form a radius. This whole line will form a radius. So since the centripetal acceleration is what should I use the word, is aligned will be a good word. Since the centripetal acceleration is aligned towards the radius of the circle, we also call it radial acceleration. And I told you where, here, also centripetal / radial acceleration. Why centripetal / radial? Because it is directed towards the center, and when you direct something towards the center, it will automatically align towards the radius of the circle. So that is why we also call it radial acceleration. And I hope this thing is clear to you. What is centripetal acceleration? Did you understand? Some small points are there in this also. ठीक है, कुछ छोटे-छोटे पॉइंट और हैं, वो भी करते हैं अभी. But just tell me if the definition is clear about centripetal acceleration. Definition and the basic meaning. Why is it arising? It is arising due to the change in the direction of the velocity of the particle. Okay. Now I will tell you the formula. Formula for centripetal acceleration. AC centripetal acceleration. We denote centripetal acceleration by alphabet AC. Okay. And the formula for this is V square by R. V square by R formula hota hai aapka. If you want to write this formula in the terms of angular constants, replace V by R omega. So you will write what? R omega square, because V is equals to R omega. You have learned this relation. ये वाला relation करा है ना आपने, V is equals to R omega वाला. So if you put the value of V is equals to R omega, V will be R square upon omega square, and R square and R will get cancelled. So the final answer will be R omega square. Okay, and if you put the value of R, which is what? V by omega. If you put the value of R, which is V by omega, you will get answer is equals to V omega. Because then omega square, if the value of R, what is the value of R from here? The value of R is V by omega. If you put this value here, you will get for formula as V omega. So these are one formula only, three different forms of a single formula. This is the main formula, V square by R. This is the main formula, and these are the arranged forms, different forms of this one single formula, V square by R. Okay. SI unit, since it is acceleration, so its SI unit will be meter per second square. Because this acceleration, because it's a type of acceleration type hai, and SI unit of acceleration is what? Meter per second square. So SI unit of centripetal acceleration will also be meter per second square. Okay. Now if I ask, first let me see if you are clear or not. Many of you, okay sir, okay. Are you clear? Now tell me about centripetal acceleration, the formula, the definition. समझ में आई चीजें? Quickly. जब तक आप लोग बोलते हो तब तक एक क्वेश्चन भी कराई देते हैं. Everybody please respond. Are you clear about centripetal acceleration? Okay, I have written the question for you. We'll solve this question after discussing one small concept. Until then, let me see. Clear, clear, clear. Yes, sir. Yes, sir. Yes, sir. Okay, good. Good. Now, tell me one thing, everyone. Just tell me a very simple question I'm asking you. Uh, will centripetal acceleration be constant in uniform circular motion? Do you understand my question? Will centripetal acceleration be constant? Okay. Do you, all of you understand the meaning of the word constant? So I'm asking, will centripetal acceleration be a constant quantity in uniform circular motion? यूनिफॉर्म सर्कुलर मोशन के अंदर सेंट्रीपिटल एक्सेलरेशन कांस्टेंट होगा या फिर उसकी वैल्यू चेंज होती रहेगी? जस्ट टेल मी whether the value of centripetal acceleration will keep on changing or it will remain constant throughout your uniform circular motion. Okay, just tell me, everyone, quickly think and tell me in 20 seconds. 20 seconds. बताओ भाई, क्या यस सर क्या होता है बेटा? ये बताओ, चेंज होगी विल यूनिफॉर्म सर्कुलेशन? अच्छा, क्वेश्चन का आंसर आप दे रहे हो. क्वेश्चन में ये कर देता हूँ, इज सेंट्रीपिटल एक्सेलरेशन कांस्टेंट? मैं ना कंफ्यूजन होता रहेगा. दीपिका ने आंसर तो दिया लेकिन मैं कंफ्यूज हो गया क्योंकि मैंने क्वेश्चन फ्रेम नहीं किया ना. कौन सी स्टेटमेंट पे यस बोलो उसने. द क्वेश्चन इज centripetal acceleration constant in uniform circular motion? UCM. What is UCM? Uniform circular motion. Okay, now tell me your answer, yes or no. Let me see. इसमें पोल भेज सकते हैं ना भाई? आप लोग रिस्पॉन्ड क्यों नहीं कर रहे हो? मुझे आगे पढ़ाना है. दीपिका के अलावा कोई रिस्पॉन्ड नहीं कर रहा है. Okay, so 33% says no and 67 says majority says yes, but the answer is no. What to do with majority? किसको किसको लगता है कि यस होगा? प्रतिभा को लगता है और दीपिका को और प्रसन्ना को. आप तीनों को ही लगता है कि मलिनी ने आंसर नो दिया है. What to do in this case? I have to explain. What else? और क्या कर सकते हैं? See, the answer is no. Answer is no because centripetal acceleration is a vector quantity. किसी भी तरह का acceleration हो, any type of acceleration is a vector quantity. Okay, and vector quantity has magnitude as well as direction. And since you are moving in circular path, because it is uniform circular motion, your direction is continuously changing. And if direction is getting changed, your acceleration is changing. So centripetal acceleration will not be constant. So the answer is no, it will not be constant because direction is changing throughout the circular motion. And due to this reason, the centripetal acceleration will not be constant, although the magnitude of centripetal acceleration will be constant. So magnitude will be constant, but centripetal acceleration as a whole will not be constant due to continuous change in direction of the particle undergoing circular motion. नहीं आया, सबको आ गया होगा अब तो. Okay, solve this question then. Quickly solve this question. The question says a particle is moving in a circle of radius 5 centimeters with constant speed and time period 0.2 pi second. 0.2 pi second. This is the time period 0.2 pi seconds. The acceleration, this is the acceleration. What I'm asking, acceleration short form में ऐसे लिखूंगा मैं. The acceleration of particle is, I'm asking acceleration. I've given to you the radius of the circle in which the motion is taking place. I've told you that the speed is constant and the time period of the particle to complete one circle is 0.2 pi seconds. You have to tell me acceleration. Okay, 1 minute to solve the question. Are you able to solve, guys? Let me see. सर मैंने भी नो ही दिया था आंसर. अच्छा, then good. आपको कौन सा समझ में आ गया? Congratulations. थ्री इडियट्स देखिए आपने? दीपिका, थ्री इडियट्स में ऐसे बोलता है ना प्रोफेसर वीरू सहस्त्र बुद्धि, especially in that scene with scene लाइब्रेरियन को, लाइब्रेरियन goes to his room and लाइब्रेरियन कहता है कि सर आपने मुझे याद किया and he says no sir I'm librarian, मैं permanent हूँ. He says in this specific tone, congratulations. दीपिका को रेफरेंस समझ में नहीं आया शायद, बट एनीवेज क्वेश्चन सॉल्व करो. 10 seconds मोर कर लोगे 10 सेकंड में? लग तो नहीं रहा है मुझे. Anybody start giving answers, random answers, कुछ भी दो लेकिन दो, because this the time is enough time for solving. Guys, अच्छा मुझे पता कैसे चलेगा कि आप लोगों को आया है नहीं आया है? If you'll not give answers, how will I get to know this? 5. Okay, my name is answering 5. Okay, I'll start solving because आप लोग को तो बिठा के रखो, मजा आता है आपको, है ना? इतना कितना टाइम लगाते हो यार एक क्वेश्चन सॉल्व करने में? मुझे समझ में नहीं आता कि मतलब अगर क्वेश्चन नहीं आ रहा है तो एटलीस्ट बोल दो कि सर नहीं आ रहा है, ताकि हम आगे बढ़ सकें। इसी पे क्वेश्चन पे बैठे रहते हो, एक ही क्वेश्चन पे। मेरा कुछ नहीं है, मार्च आएगा उतना बाद जितना होगा होगा, मैं बंद कर दूंगा सिलेबस। बोलूंगा बच्चे पढ़ते ही इतना धीरे थे, मैं क्या पढ़ाता हूँ। छूटेंगे लास्ट के चैप्टर्स। जितना टाइम आप लोग लगाते हो उतना थोड़ी लगाते हैं यार। इस हिसाब से करोगे तो आपकी बायो भी पूरी नहीं हो पाएगी 3 घंटे में, जिस हिसाब से आप सॉल्व करते हो। खैर, the question is very easy because constant speed is given to us. Constant speed given means what is type of motion? It is uniform circular motion. Speed constant है तो कौन सा motion हो रहा होगा? Uniform circular motion. सिंपल सी बात। रेडियस कितना दिया हुआ है? 5 सेंटीमीटर। ठीक है, मीटर में कन्वर्ट कर लोगे 5/100। ठीक है, क्योंकि वेलोसिटी आपको एक्सेलरेशन निकालना है, मीटर पर सेकंड में होता है तो 5/100 कर लोगे। ठीक है, एंड टाइम पीरियड आपको दिया हुआ है 0.2 पाई। ठीक है, सेकंड्स, 0.2 पाई सेकंड्स। ठीक है, और अब एक्सेलरेशन का आपको एक फॉर्मूला सोचना पड़ेगा, ऐसा जो 3 फॉर्मूले पड़े थे सेंट्रीपिटल एक्सेलरेशन के। ठीक है, उनमें से ऐसा फॉर्मूला सोचना पड़ेगा आपको कि जिसमें आपको टाइम पीरियड की टर्म का यूज मिल जाए। ठीक है, यू हैव टू थिंक ऑफ दैट फॉर्मूला ऑफ सेंट्रीपिटल एक्सेलरेशन इन विच यू कैन अप्लाई this term time period, and that formula is AC is equals to omega square r, because we can write omega as what? omega कैसे लिख सकते हो? 2 pi by t। ये वाला फॉर्मूला पढ़ाया था मैंने। You can write omega as 2 pi by t. Okay, and only time period is given to you, so you have to select this formula, omega square by r. That is why you have to select this formula. Out of all the formulas, you will select omega square by r because time period is given to you. Because time period is given to you, and in order to solve the question using time period, you need to apply this formula. So लगाओ तो फॉर्मूला, क्या दिक्कत है? 2 पाई अपॉन 0.2 पाई square times radius, which is 5/100. So pi and pi cancel, point will go here, and 2 tens are 20. 2 tens are 20. 10 square is 100. So AC will be 100 into 5 upon 100. So 5 meter per second square is the right answer. I hope the solution is clear to you. If not, what can we do? Okay, टेंजेंशियल एक्सेलरेशन के बारे में पढ़ते हैं। बहुत टाइम हो गया, मैं सोचता था एक और क्वेश्चन कराऊं आप लोगों को, बट आप लोग वही क्वेश्चन में 2 क्वेश्चन का टाइम ले जाते हैं। टेंजेंशियल। Now what is tangential acceleration? Net acceleration पढ़ाया था। Yesterday we learnt about net acceleration. Okay, यहाँ net acceleration में मैंने आपको बताया था दो चीज, they have used 2 different components, AT and AC. So AT is your what? AT is your tangential acceleration. AT is your tangential acceleration. And tangential acceleration AT is directed along the tangent to the circumference or to the circle. What will be the direction of tangential acceleration? Along the tangent. Basic सी बात है, along the tangent. So if I write the definition, it will be somewhat like this. The tangential acceleration is present only in non-uniform circular motion. In non-uniform, what is the meaning of non-uniform circular motion? What is the meaning of non-uniform circular motion? Means when the speed of the particle is continuously changing in throughout the circular motion. Okay, you see here, what is non-uniform circular motion? That tangential speed is variable. I've told you in circular motion there will be two type of speeds. Okay, there will be two components of speed. So the tangential component of the speed is variable. Tangential component of the speed is variable. There will be two components, radial and tangential, and the tangential component, भाई ये सारी बातें बताई थी ना आपको सर्कुलर मोशन में जब पार्टिकल होता है तो स्पीड के बेटा दो कंपोनेंट होते हैं, रेडियल और टेंजेंशियल. सो इन यूनिफॉर्म सर्कुलर मोशन द टेंजेंशियल कंपोनेंट this is your velocity, yeah, this is your velocity, it is in this particular direction. It will have two components, one this and the other one tangential. Okay, so this is your AT, tangential component. So when the tangential component of the speed is variable means it is changing continuously with time. So in that case your tangential acceleration will be non-zero. It will be non-zero, and acceleration, tangential acceleration is equal to dv by dt, rate of change of tangential speed. Tangential acceleration is equal to rate of change of tangential speed. ठीक है, इसको थोड़ा सा बेटर करके एक्सप्लेन कर देते हैं. Let me just better this. So if I say if speed of a particle in circular motion is changing continuously, then it will also change magnitude of velocity. देखो मैं क्या लिख रहा हूं ध्यान से. If the speed of the particle in circular motion is changing continuously, if the speed of the particle is changing continuously, it will also produce change in magnitude of velocity. Or if you get this point, this I have repeated 100 times here. What is magnitude? What is the पूरा chapter ही पिछला वाला इस पे ही था. Vector chapter was entirely based on what is magnitude, what is the difference between speed and velocity. Okay, all of you have studied this, and if you have not studied, not my fault, because I've already recorded videos are there, everything is there. So the speed of the particle in circular motion is changing continuously, then it will also change the magnitude of velocity, and due to this change, we will have what? Tangential acceleration. So tangential acceleration is due to change in magnitude of velocity. Centripetal acceleration was due to change in direction of velocity, whereas tangential acceleration is due to change in magnitude of velocity. Okay. Okay. And I've already told you acceleration tangential AT will be equal to dv by dt, rate of change of tangential speed. Okay. Now tell me one thing. If I'm saying speed of the particle is changing in uniform circular motion, speed of particle is changing, then we understood that magnitude of speed, magnitude of velocity, this is magnitude of velocity, will also change. Magnitude will change. Just tell me, will omega change? Tell me this. Will the angular velocity change if the speed is changing? Just tell me this. Will the angular velocity change if the speed of the particle is changing? बार बार पोल क्रिएट नहीं करूंगा मैं, आलस आता है मुझे, ऐसे ही बताओ। विल दी, बताओ भाई प्लीज। Why you took 100? Why you took 100? Where, Prasanna? Where I took? Prasanna, just open your mic and tell me why you took 100. मलिनी, मेरे को ना एक बार बता दिया करो एक बार ना प्लीज, कि मैं सर एक बार चैट देख लो, मुझे लगा था कोई डाउट होगा नहीं। मलिनी, I took 100 at two places. First 100 was here because I want to convert radius which is given in centimeters to meters. Okay, so I divided by 100. That's how you convert centimeter to meters. Fifth class mathematics. So that is why I took the first 100. Now again I took 100 here. This is calculation of this part. Omega square. I calculated omega square r. Omega square r. Omega square was what? Omega is 2 pi by t. T is given to you as 0.2 pi. So square of this. 2 pi into 2 pi is upon 0.2 pi into 0.2 pi. So pi and pi will get cancelled. Pi and pi will get cancelled. Okay, this 0.2. Understand one thing, 1 upon 0.1 can be written as 10 upon 1. If you remove this decimal, you have to add 1 0 in the numerator. This is the basic mathematics. Okay, so if I remove one decimal from here, I will add 1 0 here, and if I remove one decimal from here, I will add 1 0 here. So this becomes what? This becomes what? 400 divided by 4, which is 100. Okay, that's why the second 100 came. This is the second 100. So 100 into 5 by 100, 100 will get cancelled. The answer will be 5 meters per second square. Now tell me whether the angular velocity omega will change if the linear speed is, if the speed of the particle is changing. If the speed of the particle is changing, will the angular velocity change? Malini is saying yes. Only Malini is saying yes. Others are saying nothing. Pratibha ko kya ho gaya? Dubika ko kya ho gaya? Prasanna ko kya ho? Prasanna, what happened to you? Why are you not answering my second question? And what about Pratibha? प्रतिभा, सिर्फ स्कूल के एग्जाम में मन लगता है या मन नहीं लगता है क्या? यस सर. यस प्रसन्ना. Now you want to say something? Okay. The answer is yes, because V is equals to R omega. So if there is change in V, if V is changing, omega will definitely change, increase or decrease, whether the V is increasing or decreasing. Okay. So yes, omega will change. Omega will change. And if omega will change, alpha will be there. Angular acceleration will be there. If angular velocity is changing, angular acceleration will be present. So angular acceleration will be present. Yes or no? This is clear. Now remember the relationship between tangential acceleration and angular acceleration. Okay, so tangential acceleration AT tangential acceleration is equals to radius times angular acceleration alpha. Okay, remember this relationship between tangential acceleration and angular acceleration. This is very, very important. Okay, and do you understand why angular acceleration क्यों present होगा? Non-uniform motion में, in non-uniform motion tangential acceleration will be there. Why? Because change in magnitude of velocity is taking place. That is why tangential acceleration is present. And since tangential acceleration is present, then angular acceleration will also be present. Okay, because tangential acceleration will change your angular velocity, and change in angular velocity will produce what? Angular acceleration. So that is the relation. AT is equals to R alpha. ठीक है? Net acceleration we have already done yesterday. We have done net acceleration. You see this net acceleration अपन ने करा था ना. Net acceleration is tangential plus not angular in this case. अब इसको क्या कर दो, tangential plus centripetal. वो समझने के लिए आपको बताया था मैंने. ठीक है, अब इसमें बात करेंगे. नॉर्मली सर्कल के केस में ना लीनियर एक्सेलरेशन को ही नेट बोलते हैं. नेट एक्सेलरेशन जब आप बोलते हैं तो यू ओनली अकाउंट फॉर योर लीनियर एक्सेलरेशंस एंड नॉट योर एंगुलर एक्सेलरेशन नॉर्मली. ओके, बट इट इज नॉट द केस ऑलवेज. पर आपको नीट में ज्यादातर यही मिलेगा. आई डोंट थिंक आपके लेवल पे टोटल एंगुलर एक्सेलरेशन में एंगुलर को इन्वॉल्व करेंगे वो, बिकॉज 3 वेक्टर्स का समेशन आप लोगों को 1 मिनट में सॉल्व होने वाला पड़ेगा नहीं. ठीक. तो total acceleration is the vector sum of centripetal acceleration and tangential acceleration. How do you vectorly sum? You square the components and add them inside a square root. Okay, that is your a total. How will calculate total acceleration? Square root of tangential acceleration plus centripetal acceleration. Okay, and if tangential acceleration is towards the tangent, so this is direction of tangential. Centripetal acceleration is towards the center. So both the accelerations are at 90 degree from each other. You can see this tangential acceleration और centripetal acceleration दोनों एक दूसरे से 90 डिग्री का एंगल बनाते हैं. Both the accelerations are present at 90 degrees from each other. So the resultant will be in between them. This will be total acceleration. Okay, what will be theta? This is, if this is theta, this is theta, tan theta will be equal to opposite AT upon adjacent AC. That is the formula here. छोटी छोटी बातें ये तो आपको देख करके आ जानी चाहिए. थीटा देखो बेटा, इसको लिया है, इसको थीटा लिया है. This is theta, this is theta. ओके, तो ये थीटा होगा तो ये क्या होगा, अपोजिट अपॉन एडजेसेंट. अपोजिट क्या है आपका 80 और एडजेसेंट आपका क्या है AC. तो 80 अपॉन AC, अपोजिट अपॉन एडजेसेंट. थीटा इज अपोजिट अपॉन एडजेसेंट. नाउ व्हाट डू यू वांट टू डू? यू वांट टू डू टाइम क्या हो गया? 6:36 already. Okay, let me give you a simple question and we will end this then for today. What is that simple question? Speed of a particle moving in a circle of radius is equals to 4 meter varies or changes. Varies means changing, varies with time, as v is equals to, good question, v is equals to t square, where t is time, t is in seconds, and v is in meter per second. Find net acceleration. Acceleration at time is equals to 2 seconds. At time is equal to 2 seconds, you have to calculate your net acceleration. Okay, v is equals to t square is the relation between speed of the particle and the time period. This is the relation. Using this relation, you have to calculate, and the radius of the particle is 4 meters. The radius of the circular path is 4 meters. You have to calculate net acceleration. करके दिखाओ, अब करके दिखाओ. Try to solve the questions. Calculate centripetal acceleration, then calculate tangential acceleration, and then add them. सर ये तो जैसे हमें पता ही नहीं था, बहुत अलग कुछ बात बता दी. हाँ जी, solve the question. Everybody must solve. Nobody is solving. क्या क्लियर प्रतिभा? Is clear of second question? अच्छा, okay. I got it. Yes, everybody, please try to solve the question. This is the question. Speed of the particle moving in a circle of radius 4 meter varies with time as v is equals to t square, in where t is in seconds and v is in meter per second. Find the net acceleration at time is equals to 2 seconds. ये जल्दी करो. You have zoology class lined up. Quickly, if you will solve this, then you will be able to attend zoology class. Then you will be able to get your peace of mind and whatnot. Tick tick 5, tick tick 4, tick tick 3, 2, tick tick 1, tick tick 0. Boom. 4 pi square. Okay, क्वेश्चन दिखाओ सर. दिखाऊंगा तो जल्दी कर दोगे. क्वेश्चन में ऐसा तो कुछ है ही नहीं जो आपको एक बार में याद ना रहे. रिलेशन है v इक्वल टू टी स्क्वायर, रेडियस 4 मीटर है. बोल भी रहा हूं मैं. t इक्वल टू 2 सेकंड पे आपको एक्सेलरेशन बताना है नेट. 4 pi square. One answer has, Vikin Prasanna has become first this time in answering. Okay, let's check Prasanna's answer. Net acceleration, net acceleration, net acceleration. A net is equals to AT plus AC. ऐड हो गया. ये क्या हो रहा है? AT plus AC. Okay, that is what your net acceleration. Now equation is v barabar t square. How will you calculate centripetal acceleration? You have to calculate both AT and AC. How will you calculate AC? AC will be v square by r. What is v square? V is equals to t square. So you have to calculate net acceleration at 2 seconds. So you will write, keep 2 here, 2 square upon what? 4. So this will be नहीं, t स्क्वायर रखा ना यहाँ पे. मैं t ही 2 है तो t का स्क्वायर 4 होगा. यहाँ पर आपको 4 स्क्वायर रखना है. Because t value, you have to calculate the net acceleration at 2 seconds. So you will put t value 2 and t value is 2. Then the square of the t value is 4. Okay, and then the net AC is your velocity square. So 4 square. So that will be 16 upon 4 is 4 meter per second square. This is your centripetal acceleration. What is your tangential acceleration? Tangential acceleration is dv by dt. Okay, so differentiation of v is equal to t square will be 2t. So at t barabar 2 seconds, at put t value is equals to 2, you will get the final answer as 4 meter per second square. So both the accelerations are 4 meter per second square. A tangential and central also is 4 meter per second square. A centripetal. So their resultant will be what? I have told you when the two vectors are equal and inclined to each other at 90 degrees, their resultant is, if this is A and this is also A, two equal vectors, the resultant is root 2a. Your final answer will be 4 root 2 meter per second square. Okay. So Prasanna, the pi was not required. You have to need to calculate 4 root 2. Okay. So I don't know from where you have got the answer in the terms of pi, but okay. Not a problem. Root 5. कैसे? पता नहीं जी कैसे मतलब. हाँ, मालिनी का रूट 5. हाँ, इसको अंदर आगे सॉल्व कर लो आप. ओके, नाउ दिस इज इजी. कैलकुलेशन ही था, उसके बाद तो आप लोग कैलकुलेट कर ही लोगे. ठीक है भाई. मालिनी एंड प्रसन्ना, जस्ट लुक अपॉन योर मिस्टेक्स of this question and we will meet tomorrow, and we'll study from here only. Okay. AC is equals to omega square. No, you don't have to use omega square r. I have not given you angular velocity. So how can you use that? Okay. I've given you linear velocity directly, so use it directly. This will come with practice, Prasanna. Don't worry. This will come with practice. When you will see more questions like this, you will get which formula to select. You will get this only by practice. So practice more questions at home and then ask your doubts. Then only you will get it. Why I have taken v square by r and not omega square by r. I could have taken omega square by r when angular velocity was given, but linear velocity was given. That's why I've taken v square by r. Okay. That's it for today. We'll meet in the next class. Goodbye, everyone.